Some triangles are really special because they enjoy so much symmetry in the sense that sides are equal or angles are equal, and there's sort of a great celebration of things that look nice. So let's talk about the famous Isosceles triangle. And here are two really important results. The first one is the Isosceles triangle theorem, which states that if two sides of a triangle are congruent, then the angles opposite the sides are congruent. And so basically, if you look at this little picture right here, if we know that these two sides are congruent, then the angles opposite are going to be congruent as well. It's a great property that's really handy whenever we're dealing with isosceles triangles. And the converse of the isosceles triangle theorem also is a theorem, and that states that if two angles of a triangle are congruent, then the sides opposite the angles are congruent. So, if you have two angles and you know they're congruent, then in fact, the sides that are opposite, they will be congruent as well. So in fact, this is congruent to that. Neat. Now let's see this theorem in action. So here we go. Suppose that we're given that C is the midpoint of BD, and the measure of the measure of angle ABE is 105 degrees. So let's take a look at this picture. It's given to us. And so we see that C is the midpoint of BD. So there's a line segment, and C is the midpoint. Okay, great. Then we know that the measure of angle ABE, so that big angle right there, that obtuse angle, is 105 degrees. And we know that the measure of angle CDE, so that little angle right there, is 75. So this is 75 degrees, so that's pretty neat. Write that right in there. And that's all we know. And now we're supposed to give a justification for why we know for certain that, in fact, BE, that length, is equal to ED, that length. Why are these two lengths the same? And it's not just a matter of looking at the picture and saying they look the same. We need to explain mathematically why. Well, let's think about this. Seems kind of tricky because it doesn't seem like we have a lot of information. But when we look closely, we notice that, in fact, this angle together with this angle are actually supplementary angles because, in fact, we see they lie on this line. So therefore, if I take 180 degrees and subtract off the 105 degrees, that will tell me exactly what the measure of this little angle EBC is. And so if we take 180 and subtract 105, we see 75 degrees for the measure of that little angle right there. Well, wait a second. Look at this. Forget about all that stuff. We've already used that. Let's now see what we've got. I've got a triangle here, and I see that this angle and this angle actually have the same measure. Therefore, these angles are congruent, which tell me automatically that the opposite sides will be congruent. So therefore, this side is congruent to this side. That is, BE is congruent to ED, and that means that, in fact, they have the same length. And that, in fact, proves the little result. Neat.